quadratic is a polynomial in the form ax squared plus bx plus c, where a, b, and c are numbers. There are 4 ways to solve a quadratic. They are using the square root property, completing the square, quadratic formula, and factoring. This video will focus on completing the square. Other words for solving a quadratic are finding the x-intercepts, finding the roots, or finding the zeros. Let's just walk through an example and then we can talk through steps. So for this first one, we need to complete the square. We're going to solve x squared plus 6x minus 13 equals 0. The first step when you are solving by completing the square is you want to add or subtract any constant over to the other side of the equal sign. Okay, and then I left this huge space here because I want to fill this in with something that'll make the left-hand side something nice to factor. And remember, whatever you do to one side of the equal sign, you have to also do to the other side. So whatever number I put here, I'm going to add to 13 as well. Okay, so let's fill it in with something that'll make that left-hand side easy to factor. What should we use? Let's use a 9. Okay, I put a 9 there, I put a 9 there. Side note, just think to yourself off to the side, let's factor x squared plus 6x plus 9. Okay, we need to come up with 2 numbers that multiply to 9 and add to 6. Oh, 3 and 3. 3 times 3 is 9 and 3 plus 3 is 6. So notice that left-hand side factor. Okay, we've actually done the hard part here. We added some number to make this left side easy to factor, and now this looks just like the problems we did when we solved using the square root property, that example 3 from the video that hopefully shows up in the right-hand corner here. So now all that's left to do is we need to solve for x. That means we have to get rid of that plus 3 and we have to get rid of that squared. Okay, let's get rid of the squared first, so we'll square root both sides. Don't forget, this original problem did not have a square root in it. I had to draw that in extra as part of my solving. That means the plus or minus is super important. Do not forget plus or minus. If you can break down your square root, break it down, but 22 is just 2 times 11, so I don't have a pair of numbers to pull out. That's it. And then the last step is I need to subtract my 3 over to the other side. And now this problem has been solved. How did I know to put a 9 here? It's a pattern. If we did this enough, hopefully you would pick up on what the pattern is, but for sake of time, I'm going to just tell you. What I did was I divided my 6 by 2 and got a 3, and then I squared my 3 to put it in the blank. So you want to always take your b term and divide it in half, and then square it and add it to both sides of your equation. Let's talk through our steps, or recap what we just did. So first we rearranged the equation into x squared plus 6x equals 13. So you want to always move your constant c value over to the other side of the equal sign. I put this step in here because I wanted you to have complete notes. You can complete the square if you have an a value, but in this class, we're not going to. We are only going to complete the square if a equals 1 down here at the bottom. It gets really messy and you have to deal with fractions if you do have an a value, and that's more complex than we want to get this semester. But know that if you did have an a term, you would divide all 3 of these terms here by a, and that would get rid of your a, and now everything else would be fine and dandy. Continue your steps. All right, next, I took this value here, this b, and divided it in 2. Technically, if you had divided by an a already, then it would be divided by 2a. But you take your b value, you divide by 2 and square it, and that's what gets added here. I'm going to call it d squared just because it's less writing than having to write b over 2 squared. But that's what we're adding up here to both sides of our equal sign. Now you can factor this left-hand side. Either factor it by thinking what multiplies to d squared and adds to b, or it's always going to follow this pattern here. X, this is the sign of b, and your d value, and you always put it in parentheses squared. And on the right-hand side, you're always going to add a positive number, never a negative. So even if b is a negative, we're going to add the positive number to it. Simplify that right-hand side and now solve for x by taking your square root, don't forget your plus and minus, and subtract your d over. In my notes that I'm going to link along with this, I tried to walk you through trying to do completing the square with this equation here, so you should probably try it yourself. I'm not going to do it in this video, but hopefully after seeing these 3 examples and having that little walkthrough, you should feel fairly comfortable with it. We'll see. Let's do 2 more examples to help solidify this in your mind. So example 2, solve or find the x-intercepts of x squared minus 8x equals negative 15. So it's already rearranged for us. We already have our constant whole number, the c value by itself. We just need to figure out what we want to fill into these blanks here. So that way I can factor this left-hand side nice and pretty. Okay, so divide your value, your b value by 2. That's going to be a 4. And then 4 squared is 16. On the left side, if I wanted to factor that, I would say what multiplies to 16 and adds to negative 8? Well, negative 4 and negative 4. Or you can just use the pattern. It's going to be x, this sign of your b value, and then that b over 2. All squared. On the right-hand side, add those 2 numbers together. Remember, it's always adding a positive number. So negative 15 plus 16 is 1. And now last step, solve. So I need to square root both sides. Don't forget a plus or minus. And the square root of 1 is 1. And then add your 4 over to the other side. Because this 4 and this 1, they're both constant whole numbers, I can combine like terms and add them together. So because I don't have any more square roots, actually take this last step. What is 4 plus 1? And what is 4 minus 1? If I go back to the original problem and sub in a 5 for both of these x's and a 3 for both of these x's, I'll get a negative 15. That's how you check your work. Also, if I plotted this on a coordinate plane, my x-intercepts would be positive 5 and positive 3. Let's do one last example. Solve or find the x-intercepts, find the roots, find the zeros, and we're going to use completing the square. So rearrange it. I'm going to add my 4 over to the other side of the equal sign. I need to figure out what to put in this blank here. So divide your 12 in half to get a 6 and square it. All right, factor the left-hand side. What multiplies to 36 and what adds to 12? 6 and 6. Or remember our pattern, x, this sign, and this number, all squared. On the right-hand side, 4 plus 36, add those 2 together, and now we are left solving. So take the square root of both sides. Don't forget your plus or minus. Simplify your square root if you can. In this case, I can pull out a pair of 2's. And now subtract your x over to the other side. We can check our work if we sub negative 6 plus 2 square root 10, and for both of these x's we get a 0, and if we sub in negative 6 minus 2 square root 10, and for both of these x's we also get a 0. If we wanted to check our x-intercepts, that would be what these 2 numbers are.